Hello, this is Group 9. We have been asked to design a system that allows rooms and locations in a large organization to be searched and booked. Our supervisor for this project was Dr. Graham Roberts. The organization of choice was our home university, UCL, as it was convenient to interview lecturers and students, who are mainly the target audience of the system. We propose a system that is far simpler to use, and it also includes a room swapping facility. In this presentation, we will talk about the human-computer interaction components, the key requirements and the use cases, the object-oriented design, including UML diagrams, a mock-up, and finally an evaluation section.
The human-computer interaction aspect of the project consisted of an analysis of similar systems, an interview with the client, creating personas representing those who use the system, HCI requirements, and an early prototype. The interview was conducted from lecturer and student perspectives to generalize user requirements. From the lecturer's perspective, important issues of the system included lack of user-friendliness, lack of a built-in way to communicate between bookers, and lack of clarity on how to cancel bookings. The lecturer also mentioned handy additional features, including a room swap feature that facilitates communication amongst users, campus maps showing room locations, and a mobile interface for smartphones and tablets. The student interview was much shorter but provided additional insight. Important points brought up included that students would mostly use the system for short notice and non-recurring bookings for study spaces. They may book for society meetings as well, and that the current system does not support direct student use, so implementing that may be useful. We did a competitive analysis of 3 systems: UCL's, University of Pennsylvania's, and University of Washington's. An analysis of UCL's system showed that we need to find an easy way to book lecture and study rooms through the same system. Booking needs to be a step-by-step process for new users that can be circumvented by experienced users. It needs to show room information clearly so users can view or ignore what they want to, and it needs a straightforward form with no open-ended questions. University of Pennsylvania's system showed us that having the form expand as the user provides information helps to narrow down choices based on users' needs. Also, that we shouldn't overwhelm the user with too much information. Tracking user activity is important to eliminate redundant steps, and it is important to integrate different booking sites with a single institution. The analysis of University of Washington system revealed that we need an integrated lecture and group study room system. It needs user and password protection. We need to find a fair way, possibly not first come, first serve, to decide who gets which lecture rooms. It needs pictures and room layouts, and it needs a clear start and end to the room booking process with clear choices and selections. Our lecturer persona was 52 years old and had been teaching for 16 years. He was also award-winning and popular with students, but not fond of technology, especially over complicated systems. We thus formulated that we need a simple-to-use and intuitive system. Our student persona was a second year at UCL interested in history and research, president of a society who organizes events for the department, and technologically proficient, checking emails, Facebook, and phone calls often. From this we reasoned that the system needs advanced features for those who know how to use them. From all the previously mentioned HCI preparation, we gathered system requirements using a lightweight Volair framework. Some of the important requirements included the room swapping interface, providing room and floor numbers in the information, short notice bookings and deadlines to be taken into account, swap suggestions, better usability, notification system for changes to the booking, and a mobile app and interface for the system. From requirements gathered during the HCI process, we were able to mock up early stages of the system our client desired, shown as a sample login screen. Shown here is the account page with multiple options. The first path we follow is Make Booking. This Make Booking search form is for finding a specific room a user has in mind, which leads to a single result, which the user can select. The other option is to search a room by user's needs, which is a separate form. The search results thus appear in order of best match. From the account page, you can then select Manage Bookings to view all your bookings.
Requirements are highly needed in order to create a solid base for the use cases of the system. In our project, we separated the requirements of our system in 9 different categories: general, user setup, login and security, searching activity, booking and managing bookings activity, messages and notification feature, system administration and performance of the system. We collected 48 basic requirements, which were categorized on type, activity and priority importance. For example, a must-have priority would be requirement number 17, which defines that our booking system must offer advanced search option. This shall enable the system to find rooms that will match the user's needs of equipment, such as projectors, whiteboards, and access to the library, etc. After that, we were ready to work on the use cases. These had to designate what would happen when, for instance, the user tried to log in the system and in the case that the login was invalid. Later on, depending on the user's choices, we had to prescribe what would happen if one wanted to book a room, manage his bookings, and created or answered on a request of room swap. Moreover, our system should be ready to provide alternative flows in case something went wrong with the use or the user made an unexpected choice. This way, we determine the action of the system in any possible case and set the basis for the human-computer interaction.
We design a UML use case diagram as a translation of the identified use cases just mentioned. It provides a visual representation of the problem domain of our room booking system. The diagram clarifies the different actors of our system, the system boundary. It summarizes the different functionality of our system and provides a visual representation of their basic relationship. An actor of a system is an entity that interacts directly with the system. The actors of our system includes the account owner and the original booker. The account owner represents the current user that is able to log into the room booking system via his or her university account details, while the original booker refers to one that has booked a particular room and is contacted by the current account owner for a request of swapping rooms. We now provide a brief description of each use cases of our room booking system. The large rectangular box represents the boundary of our system, and all the use cases are defined within the system boundary. Individual use cases are labeled according to their respective ID in the system's use case table. Use case 1, login, is when an account attempts to log into the room booking system. Use case 2, book room by needs, is when the account owner searches rooms by some certain criteria and books a room based on that criteria if such room is available. Use case 3, book specific room, is when the account owner has an exact room in mind and books that particular room if available. Use case 4, cancel booking process, is when the account owner chooses to exit from the room booking process. Use case 5, request room swap, is when an account owner wants to book a room that is unavailable. He or she notifies the original booker of a particular room to request for swapping rooms. Use case 6, submitted swap request, is when the account owner wishes to cancel a swap request. Use case 7, manage bookings, is when an account owner logs into his or her account and look up the bookings they have already made. Use case 8, view notification, is when the account owner gets informed about any changes in their bookings. Use case 9, accept swap, is when the original booker of a room accepts the offer by the account owner for a swap of rooms. Use case 10, booking recurring events, is when the account owner selects a room and time to book and has the status level to book a recurring event. The following activity diagram describes the flow of a booking reminder feature in our booking system. The system walks through the full list of rooms and determines if a particular room has been booked or not. If a room is booked, it checks if the booking time of the room is within 24 hours and sends a notification to the account owner that booked the room. The activity diagram shows the password-protected login/logout mechanism of our room booking system. The system requests the account owner enter his or her username and password, and the server verifies the details. If the verification process fails, the system prompts an error and requests the user to re-enter his or her details. Else, the account owner is logged into a room booking system and will be able to log out of the system by selecting the logout button.
In this section, we will be showing the key sequence diagrams of the system. Use case 1. For a user to log in, they would enter their details in the login interface. These details will be passed to the database for authentication. After this, the user is directed to the accounts page. Use case 2. For a user to search rooms by needs, they would select Make Booking from the account page and fill in their requirements. These requirements are passed to a database and the results are returned to the user. The user then selects the room or rooms they want to book. The system then books these selected rooms and sends the user a confirmation. Use case 5. For the account owner to request another user to swap rooms, they would select a book room, then select swap and input a message. These details will be passed to the original booker who has the choice to either accept or deny the swap. The account owner who requested a swap will then be notified of the result of the swap once the original booker has made the decision. Till then, the status of the swap will be shown as pending.
In order to showcase the general use of HCI and software engineering components, we created an HTML mockup that would allow a user to see the general flow of the application. The user uses a unique login and password, which then allows them to open their account page. From this page, the user has 3 options: Make Booking, Manage Bookings, and Messages and Notifications. From the Manage Bookings page, the user can view past and present bookings and their current state. This can include booked, complete, or pending in such a case where a user is waiting to hear back on a room swap. Each booking contains relevant information so that the booker can see the specifics of their reservation in a single glance. The user can choose to cancel a booking and will be required to confirm the cancellation. This prevents accidental cancellations from happening. The Messages and Notifications section sends notifications for upcoming bookings and allows users to contact each other for room swaps. The user who receives a request can generate alternatives and then choose whether or not to swap. The final option on the account page is Make Booking, which allows a user to book a specific room or click more options to book a room based on its specifications. The user can identify which qualities are important to them, and the system will match them with rooms that fit their description, both in terms of time frame and availability, as well as with size and equipment that is available. In such a case that a room is not available but fits the specifications, it will still be displayed in the search results. The option to book the room will be grayed out, but the user can then request a room swap. If the room is available, the user cannot request a swap because there's no one to request a swap from. If the user selects a room to book, the system will require them to confirm the booking. If they confirm the booking, the system books the room, else it returns them to the search results. The mockup shows the general flow of the application and is an enhancement of the HCI paper prototypes while also including the software engineering requirements. We have utilized industry standard techniques, both from the perspective of HCI for user experience and software engineering for system functionality, in order to undertake the design phases involved in the creation of a software-based product. By taking a systematic approach to gathering user requirements regarding both the user interface and the required software functionality, analyzing those requirements, formulating a logical breakdown of the components necessary to realize those requirements, and adapting those basic components using object-oriented analysis to prepare a structural overview of the system to be constructed, we believe we have undertaken this design project in a successful manner. The system documented in this report is in a state such that a software-based realization could be constructed from the object-oriented models created by our team using a suitable object-oriented programming language. The UML diagrams are sufficient such that an initial working version based upon their outlined behavior should meet all the core functionality laid out initially in the software engineering requirements. Of course, a system built upon the current framework would not be perfect and would require subsequent testing with an emphasis on end-user and expert testing to ensure that both the user experience and system functionality are adequate and meet all the requirements and constraints specified in both the HCI requirements and the software engineering system requirements. With this form of an iterative approach, convergence upon a high-quality software solution can be realized.